This is Engineering Marvels. Have you ever watched an oil tanker cruising into Corpus Christi Bay and wondered how something so large could stay afloat? An oil tanker, cruise liner, or other large ship is truly an engineering marvel with components that stretch across several engineering disciplines. But at the most basic level, shipbuilders are relying on buoyancy. The Archimedes principle states that when an object is immersed in water, the water produces a buoyant force on the object equal to the weight of the water it displaces. The buoyant force is why objects appear to weigh less in water than in air, despite the fact that gravity is still acting on them at the same rate. Buoyant force is equal to the object's weight divided by the density of water. If you look at the units in this equation, you'll see that the buoyant force is not really a force at all. It's a measure of volume. In fact, the buoyant force represents the volume of water displaced by an object. Therefore, in order for an object to float, its total volume must be greater than or equal to the buoyant force created by its weight. When you watch a ship, you'll notice that part of the ship is below water and part above. The plimsoll line measures how deep in the water a ship can lie while staying afloat. The plimsoll line is usually indicated by a change in the color of the ship's paint. If the plimsoll line is at or above the waterline of the ship, then the buoyant force pushing the ship up will support the ship's weight. Watching ships drift in and out of port can be a relaxing pastime, but the push-me-pull-you of weight and buoyance is a bit like watching a duck swim. The duck may be calm and serene on the surface, but its web feet are paddling furiously just below the water, a bit like a ship's propeller. Engineering Marvels is a joint production of the Frank H. White College of Engineering at Texas A&M University Kingsville and South Texas Public Radio. Past episodes are available online at tamuk.edu/engineering. I'm Jason Martin.